Today, when I mention reptiles, many people immediately think of various lizards. However, despite having a history of over 200 million years, this ancient species often lacks the prominence in evolutionary history compared to Mesozoic stars like dinosaurs, failing to capture people's attention. Yet, in my view, the evolutionary history of lizards represents a narrative of resilience and struggle for a marginalized species. The Mesozoic dragons we are familiar with, including Pseudosauria and dinosaurs, belong to an evolutionary branch called Archosauria. On the other hand, today's protagonist, the lizard, belongs to another branch of dragons known as Lepidosauria. Their origins trace back to the Permian period, with Lepidosauria being the ancestral group. However, the early diversity of Lepidosauria was limited, significantly constraining their evolutionary development. Unlike the dominant Archosauria, the ancestors of lizards struggled just to survive. They were a group of creatures resembling Gephyrosaurus, moving in a manner similar to their amphibian ancestors, unlike most animals of the dragons and beast groups at the time, which had robust locomotion abilities. However, this body plan, although ancient, was well suited for the environment in which lizard ancestors lived. During the Triassic period, from what is now Germany to Italy, there existed vast coastal wetlands. The semi-aquatic body plan of Lepidosauria was advantageous in this environment, allowing them to swim when needed and burrow when necessary. Additionally, the abundant insects in these wetlands provided ample food. Furthermore, most of the future rulers, the Archosauriforms, originated in the southern part of the Pangaea supercontinent, leaving a vast desert between them and the northern territories where Lepidosauria thrived. This isolation turned the habitat of Lepidosauria into a secluded sanctuary. Perhaps the environment within the sanctuary was too comfortable, leading Lepidosauria and their close relatives to be relatively conservative in their evolution. Among them, even a living fossil like Rhynchocephalia emerged. Nevertheless, there was still a branch of Lepidosauria that underwent some evolution. For instance, they improved their scales. Whether swimming or burrowing, scales effectively reduced resistance. Most importantly, these scales not only defended against insect bites, but also made it harder for predators to swallow them. The descendants of this branch of Lepidosauria are called squamata, and when referring to lizards from now on, unless otherwise specified, it refers to squamata. In the mid-Triassic period, around 240 million years ago, the earliest known lizard, Megaturella wattleri, appeared on the evolutionary stage. However, they were unlucky. As the Earth's ecology recovered, Archosauriforms finally crossed the desert and reached the lizard sanctuary. Faced with the mighty Archosauriforms, the various lizards were utterly defenseless, leading to their disappearance from the fossil record for nearly 70 million years. Perhaps nature deemed their extinction undeserved. Around 170 million years ago, in the mid-Jurassic period, lizards suddenly reappeared on the scene. By this time, the Earth's environment had changed drastically from the Triassic period, and the dominion of the Earth had shifted several times. Even Pangaea had broken apart. Yet, our protagonist, the lizard, remained familiar, still with a weak presence. However, at this time, lizards exhibited incredible evolutionary potential. For example, one group of lizards migrated to the canopy layer. They flattened their bodies and hid on trees when encountering enemies. Through long periods of evolution, this group eventually became what we now know as geckos. Moreover, Lizards that had lived within the European sanctuary began to spread outward. By the end of the Jurassic period, around 150 million years ago, the presence of lizards extended as far east as the United States and as far west as Kazakhstan, laying the foundation for their subsequent evolution. Starting from the Cretaceous period, Earth underwent significant changes. As Pangaea completely split apart, the climate became increasingly warm and humid. Marshes, jungles, deserts, and coral reefs began to expand, creating environments highly suitable for small animals. Additionally, a minor extinction event towards the end of the Jurassic period cleared out some competitors. Finally, lizards, with their small size and innate talents for burrowing and swimming, seized the opportunity to thrive and expand during this time. For instance, in the early Cretaceous period, a group of lizards evolved into iguania. They exemplified a characteristic of animal evolution, seizing any opportunity for experimentation. Previously, we discussed how vertebrates seeking flight capability had to sacrifice a pair of forelimbs. However, iguania took a different evolutionary approach. Xianglongziyui, a lizard from the early Cretaceous, directly expanded its ribs to serve as wings, albeit only achieving gliding capabilities. Nevertheless, lizards continued to experiment with obtaining flight capability. Even today, still glide using this method. Therefore, to this day, lizards have not evolved flapping wings. In addition to wings, there are also dorsal sails. While other dominants may have one dorsal sail, lizards felt that one wasn't enough. Hence, they experimented with 2, 3, or even a circle of dorsal sails, as well as bipedal locomotion, mimicking other dragons' abilities. However, the result of these experiments was. In conclusion, lizard evolution reached its peak around 40 million years ago with Chameleonidae, commonly known as chameleons. Chameleons possess horns on their heads, dorsal sails on their backs, and the fastest tongue in the animal kingdom. Coupled with independently moving eyes and the ability to change colors at will, they are arguably the most remarkable creatures. Although lizards tend to be somewhat casual in their evolutionary experimentation, their main evolutionary trajectory remains relatively fixed. Overall, the evolution of the lizard family has been focused on enhancing burrowing, swimming, and maneuverability in narrow spaces. This has resulted in many branches of the lizard family exhibiting evolutionary trends of elongated bodies and shortened limbs, as seen in Syncoida, resembling strands of spaghetti, dating back to the early Cretaceous period around 130 million years ago. However, while this evolutionary path may seem geared towards enhancing evasion capabilities, it has also fostered the strongest combat abilities within the lizard family. From the early Jurassic period, a group of lizards began to ascend the food chain, evolving forked tongues to enhance their sense of smell in the hunt for prey. To swallow larger prey whole, they evolved a remarkably flexible lower jaw. In some cases, branches of this evolutionary line even dislocated their jaws to enlarge their mouths. Thus, nearly 100 million years ago, a group of lizards gradually climbed to the upper middle levels of the food chain, known as Varanoidea. Even today, Varanoidea remains the pinnacle of combat prowess within the lizard family. Varanus priscus, which lived in southern Australia millions of years ago, even became a top predator. We can still see traces of Varanus priscus in its close relative, Varanus komodoensis, today. Varanoidea also had even sleeker relatives, which once pushed Lepidosauria to the pinnacle of evolution. One such branch is Aegialosauridae, which embarked on the lizard family's journey into the sea. Their slender bodies allowed Aegialosauridae to swim more smoothly, while their flexible jaws could create negative pressure to suck prey into their mouths. The descendants of Aegialosauridae evolved into a group of apex marine reptiles known as Mosasauridae. Coincidentally, at that time, the global oceans experienced a large-scale oxygen depletion event known as the Cenomanian-Turonian boundary event, marking the end of the Mesozoic marine wars. However, fate seemed to mock Mosasauridae. Although they had become undisputed rulers of the Mesozoic oceans, their reign lasted for less than 30 million years. The later cataclysmic event that ended the Mesozoic era, the giant meteorite impact, swiftly extinguished the glory of this marine reptile new star, leaving a regrettable mark on the evolutionary stage. Nevertheless, Mosasauridae had a close relative that still forged an immortal legend, the Ophidia, which I'll collectively refer to as snakes in the following discussion. Yes, from an evolutionary perspective, snakes are a type of lizard. Snakes have always been one of the most mysterious groups within Lepidosauria. The earliest known snake-like animal, Eophis, lived around 160 million years ago in the mid-Jurassic period. Although early snakes still had limbs, these small limbs had essentially lost their function. The main source of locomotion became the scales on their undersides. This body structure enabled snakes to adapt to various narrow environments, making it virtually impossible for small animals hiding in ground corners to evade them. Moreover, early snake species like Tetrapodophis amplectus may have already developed the method of using their elongated bodies to constrict prey. Consequently, snakes continued to evolve further down the path of limb reduction. By around 100 million years ago, the vast majority of snakes had fully regressed their forelimbs, leaving behind only a pair of small hind limbs. This body structure opened up even broader survival spaces for snakes. For example, Najash, living in Argentina, learned to ambush small animals passing through the vast plains by digging holes. Meanwhile, Pachyrhachis, inhabiting Lebanon, learned how to swim in water like an eel, utilizing its slender body. Eventually, snakes completely abandoned their limbs and remain one of the most prosperous groups within Lepidosauria to this day. Even today, some lizards maintain the traditional body forms of their ancestors. In terms of survival adaptability and evolutionary potential, the lizard family is actually quite remarkable. However, nature has not granted them many opportunities. Nonetheless, lizards continue to strive and struggle. Perhaps, at some point in the future, they too will become the new rulers of the earth.